morning, everybody. We're going to be talking about friction today. We're going to look at the role that friction plays with an object in motion, and also the role that friction plays with an object that is not in motion. So remember that there's two different types of frictions. Technically, there's three, but we deal with two main ones. Two important things to remember. When an object is moving in uniform motion, meaning uniform meaning the same, constant, so it's in uniform motion, it's constant velocity, there is no net force acting on the object. So when you look at a math problem or a math equation or a math definition of it, it's the net force in the x direction is equal to 0, and the net force in the y direction could be 0. So again, if it's in uniform or constant velocity, which means one side is not longer than the other as far as the vectors are concerned, the net force in that direction is said to be 0, or is said to be in balance. If an object is accelerating, then there is a net force acting on it. Remember that your equation is F equals ma, mass times acceleration, not mass times movement or mass times motion. So the A stands for acceleration, and that's what those FVDs will allow you to understand and view, is if an object is either accelerating or if it's moving at constant velocity. So you either are accelerating or you're not. When we get into these problems, they are going to be a little bit more complex, so you're going to need to read the problem carefully and draw in the FVDs. In the beginning, we're going to provide you with the FVDs, but as you do your own problems, it's best interest to do it correctly and draw out the scenario. So we can describe the object's motion mathematically, and that's basically what physics is, to put reasoning behind what is happening. All right, a couple of things to touch up on. Remember that there's static friction and kinetic friction, and the two are two different ones. The force of friction that keeps an object in place, it keeps an object from moving, is static friction, and that is denoted by F subscript Fs, so force friction static. Again, that's the one that you need to overcome in order to set or start something in motion. So if an object is at rest, it is experiencing friction, it's just experiencing static friction. The next type that we have is the force of friction that resists the motion of a moving object or a sliding object is kinetic friction. And that's noted by F subscript Fk for force kinetic friction. An easy way to remember this is remember the camera for Xbox. It was called the Xbox Kinect, because it was capturing motion. So kinetic is for movement and motion. Again, this is the one that you need to overcome in order to keep an object in motion. So the K stands for keeping something in motion, whereas the previous one, static, with the S, that's the one for setting or starting something in motion. And of course, we've already said this before, but it takes more force to overcome static friction than it does to overcome kinetic friction. Think about the plane pull example that you saw and we analyzed. At the beginning, you had to apply a lot more force to get it to move. Once it was moving, the strongman was able to pull the plane a lot easier, even though the force that he was applying was continuously decreasing. So to calculate the force of friction, this is just one equation. Remember, you can also calculate force of friction through net force equations, but we have just now added this equation, which is equation number 8 in our formula sheet, and that is the force of friction is equal to the coefficient of friction times F normal, or normal force. So our FF is the force of friction. The little u, that's the Greek letter mu, is the coefficient of friction. And remember that that is a number between 0 and 1. The bigger its value, the larger the force of friction. The smaller the value, closer to 0, the less friction an object experiences, or the smoother it is. And finally, we have Fn, which is our normal force. A normal force is equal to weight most of the time, except there was two exceptions that we covered last class. And those exceptions were when something is on an incline or a ramp, and when you have an object that is pulling up or pushing down on the object, even though if it's on a flat surface. So those are your two exceptions. For the coefficient of friction, remember that there is no units for it. So it's just a decimal, it's a number. And again, in on-level physics, 99.99% of your answers for coefficient of friction are always going to be a decimal between 0 and 1. The 0 and 1 itself, the whole numbers, are obviously extreme cases, and you won't be seeing that. Little test taking strategy: if you see the coefficient of friction that's negative, that's wrong. If you see coefficient of friction with a unit, that's also wrong. And if you see coefficient of friction with a number greater than 1, that's also wrong as well. So be able to look out for those and cross out answer choices. And again, this equation is only one piece that you may use in order to find force friction. You may have to use find force friction through the net force equations like we've done previously. Okay, so let's go ahead and do a few problems together. We have a rightward force is applied to a 10 kg object to move it across a rough surface at a constant velocity. The coefficient of friction, mu, is between the object and the surface is 0.2. Again, there's no units there. Use the diagram to determine the gravitational force, normal force, applied force, frictional force, and net force. Well, before we look into this, let's just go ahead and look at our diagram and stress out some important things. You see the four vectors. We have F gravity, F applied, F normal, and F friction. Those are your actual forces. While you see at the very bottom there says F net is not an actual force. It's the sum of your forces. If we wanted to break this down, we could get into F net X and F net Y. And however, this object is moving horizontally, so realistically, we are concerned with the horizontal net force. Okay, now even though the question it says gives us the order to solve for, you don't necessarily have to go by that order. And sometimes, you can pick and choose. But it's best to go ahead and do what are the easiest ones. So again, going forward, whenever you get a problem, draw the FBD, draw the correct vectors and label them, and then solve for every little piece, even though you don't think you may need it. So let's go ahead and look at this. Solve the easy ones first. And the easiest one you can always do is, as long as you have the mass, you can find Fg and subsequently Fn. That's the easiest one. Once you have Fn and possibly the coefficient of friction, like you do in this problem, then you can solve for force friction. And if you happen to have both the mass and the acceleration, you could also find net force. And once you have net force and force of friction, then you can find the applied force. So while we just went from having 5 different blanks, we just got to take small little steps in order to solve for this problem. And the easiest way to attack this is usually finding Fg and Fn. Again, if you have the mass, those are the easiest one to find. And once you solve for one thing, it starts becoming another clue piece to the puzzle, and you can use that clue to solve something else. So again, while it looks like complex, you're just doing basic stuff that you've been doing. It's just being combined into the same problem. So to calculate Fg, it's equation 9, which is mass times gravity. So Fg is equal to mass times gravity. Our mass was 10. Gravity of the planet Earth is negative 9.8. So 10 times negative 9.8, and we get negative 98 newtons. The object was flat on a flat surface. It was at rest vertically. So Fn, the support force that was exerted by the surface and in the upward direction, was equal to Fg. So the Fn is the positive version of your Fg, so 98 newtons. So now you found 2 pieces of the puzzle, and you can go ahead and put that into your diagram in the missing blanks. Now we've covered Fg and Fn. So we looked in the problem and diagram, they had already given us the coefficient of friction, the mu, and now we've solved for Fn successfully. So we can go ahead and solve for the force of friction through equation 8, which is force of friction is equal to coefficient of friction times the normal force. So we have our 0.2 as our coefficient of friction times our normal force value, which is 98. So 0.2 times 98 is equal to negative 19.6. Now the negative is because friction is to the left and we are indicating the direction. Mathematically, we didn't get a negative, but the negative is indicating our direction for force friction. And get in the habit of putting anything to the left and anything down as a negative. So force of friction for us, we just found out to be negative 19.6 newtons. And now we've taken care of 3 different missing pieces of information. As we looked at the problem and the diagram, at the very bottom, it gave us the mass of the object, which was 10 kilograms, and it also gave us the acceleration of the object. It told us that it was 0 in the diagram. The problem itself said that it was at constant velocity, which is both the same thing. When you're moving at constant velocity, there is no acceleration. This is why we also had balanced forces and balanced vectors on the horizontal side. So even though the object was moving, the force on the right and the force on the left were equal to each other, and there was no net force. Again, no net force means that the object is not accelerating. No acceleration means that the value of acceleration is 0. However, you could still be moving at constant velocity without accelerating. Again, it goes back to driving a car and putting it on cruise control at 60 miles per hour. You're not going to change your speed, but you are going to continue to travel at 60 miles per hour for however long the cruise control is. And now we found net force. So now that we found net force, it's important to remember that this was a net force in the x direction, in the horizontal direction, where the object was moving. So it had an acceleration of 0 times the mass of 10, so the net force was 0. And when we looked at our diagram, our net force in the x direction was made up of 2 different forces, force friction and force applied. Well, so far we found what the value of net force is, which is 0. We've also found what the force of friction is, which is negative 19.6. Again, the negative was because it's directional to the left. So the only thing that's remaining for us to solve for is force applied. So our equation is 0 is equal to negative 19.6 plus the applied force. So to solve for applied force, you simply add 19.6 to both sides. It crosses out the force friction, and you add 19.6 to 0, and that leaves you with the applied force being 19.6 newtons. And that's how you solve what looked to be a very complex problem by simply doing it step by step. Now, it's not guaranteed that every single problem like this will go this exact step. What you just have to do is to realize what can you solve for. So when you draw your diagram and when you have the diagram in front of you, you just start tackling the easiest ones. Whatever you can knock out, start doing it. And then before you know it, you have one clue that leads to another clue, and it eventually leads to solving the whole thing. So there you have it. Our Fg was negative 98 newtons. Our normal force was 98 newtons. Our coefficient of friction was provided to us at 0.2. We found the force of friction through using equation 8 to be negative 19.6 newtons. And our net force in the x direction was 0 because this was a balanced vector. And balanced would mean no net force. And finally, our force applied in order to keep this balanced was 19.6 to counteract the kinetic friction of negative 19.6. Okay, so now that we've solved this, let's go ahead and go to another similar problem. Okay, a rightward force of 25 newtons is applied to a 4 kg object to move it across a rough surface with a rightward acceleration of 2.5 meters per second squared. Use the diagram to determine the gravitational force, normal force, frictional force, net force, and the coefficient of friction between the object and the surface. So it's pretty much set up the similar way, except there's minor differences. Now there is a rightward acceleration, and that right arrow should be longer than it currently is. So if you're drawing it, make sure that your right vector is longer. The force applied should be longer than the force friction on the left-hand side. You do have an acceleration. So this object is obviously experiencing a net force because these are not balanced horizontally. Vertically, again, it's balanced, but we are concerned about horizontal net force. So let's go ahead and break this down as well. All right, it's similar in a setup, but then you just have to go a different path. Again, there's no cookie cutter method as of how you're going to solve these. It just depends on what you have. So first thing that you look for is, do you have the mass? And if so, again, you can find Fg and Fn pretty easily. After you have, let's say if you have Fn, then you look to see if you have the coefficient of friction. Well, in this case, we don't. So since we can solve for Fn, but we don't have the coefficient of friction, we can't solve for force friction yet. And we can't use the equation 8 right now. So we're going to have to go a different method. So that's okay. We're going to look at what we do have. Well, we have mass and we have acceleration, which means we can find our net force. So once we have net force and we already have force applied, then it goes back to what we've been doing before learning equation 8, which was that we could find force of friction through our net force equation. So there's a different way to solve for it. You don't have to always use equation 8 to find frictional force. And finally, once you have frictional force and you have the normal force, then you can go ahead and solve for the coefficient of friction. So again, just solve for what you can, one piece at a time. Don't get in the habit of thinking that there's only one equation to use and that there's only one pathway to take. Like I've said before, as of right now, you guys have learned up to 9 equations. And on any problem that you get going forward, you may be required to use any equations from 1 through 9. So again, get in the habit of writing down what you have, figuring out which one you need to use. So let's go ahead and solve this problem. All right, so finding our Fg. It's mass times gravity. Mass was 4, gravity is negative 9.8. So 4 times negative 9.8, and we get negative 39.2 newtons as our force of gravity. The object is at rest vertically. The weight of it is supported by the surface, so the upward force, the F normal, that this object experiences is 39.2, positive version of Fg. So now we've taken care of 2 different things. We can also find the net force because we already had mass and acceleration. So we take our mass of 4 times our acceleration, or horizontal acceleration, of 2.5. So 4 times 2.5 is 10 newtons. So now we find out that the net force is 10 newtons in the horizontal direction. This means that the difference between the right and left is 10. And now, again, if we want to solve for force of friction, remember that I said that you couldn't solve for force of friction through equation 8 because we're missing both friction, the force of friction, as well as the coefficient of friction. So we can't use equation 8. However, we can use what we've been using previously, which is our net force equation, to simply find a different force. So our net force in the x direction is made up of the 2 vectors of force friction on the left plus force applied on the right. We have our net force as equal to 10, so 10 replaces the F net, and then force friction is what we're solving for, and our force applied was provided to us at a positive 25. So 10 is equal to force friction plus 25. From there, it's basic algebra, subtract 25 from both sides, and you get the force of friction is equal to negative 15 newtons. And when you look at it, this problem makes sense. The negative is because it's to the left, and the absolute value of 15 is 10. There's a difference of 10 between 15 and 25. So our diagram checks out so far. we know that our force friction is correct. We know that everything else that we've done so far is also correct. Force applied is 25. Force of friction is negative 15. Again, the negative is because of the direction to the left. And now that we have force of friction and we have F normal, we can solve for the coefficient of friction. Now pay attention to what I've done there is, even though I've always said force of friction is a negative 15 in this problem, remember that we're solving for the coefficient of friction, and coefficient of friction cannot be negative. So if you get a negative answer, just check to see if you have to make it positive or if you really did something wrong. But the force of friction, the value of it is 15 newtons. Again, the negative is purely for directional purposes. So it's the force of friction is 15. The value of it is 15 is equal to the coefficient of friction times our normal force, which was 39.2. So the coefficient of friction and 39.2 are being multiplied. So now you divide by 39.2 on both sides in order to get the coefficient of friction on its own. And when you divide it out, the coefficient of friction is 0.38, which makes sense if we do our little quick check. It is between 0 and 1. Obviously, it's a decimal. It is a positive number, and we have no units for it. So there you have it. Again, what a problem looks like to be very complex, and you might be missing a lot of information. The reality is you just have to knock out what you do have in front of you. And there's no easier way than to find Fg and Fn. And then sometimes you might have to go through to find net force first, or you may be able to find force of friction through another equation. But all of these are possible. They work in similar ways. You just have to take it one piece at a time. All right, when we go to the next one, I'm leaving the next problem as a bonus question. So whoever can get this right correctly on their own and sends it to me, you can go ahead and get 5 bonus points. So I'm not going to be solving the next one, and I'm not going to be confirming whether or not you're on the right path. At another class, I will. However, it's up to you to solve it all the way throughout and work through it. So here's the question. You push an 80 kilogram box along a surface with a horizontal force of 550 newtons. The box experiences a kinetic coefficient of friction of 0.1 while in motion. What's the acceleration of the box? So the first person who is able to get the correct answer will receive 5 bonus points on the test. And I will go over this problem in a different class. So with that said, have a wonderful day. Take care.